Good morning. Let's see if this thing is even on. All right. Looks like it's good to go. All right. Let's see here. All right. So this is day 2 of clouding coffee. Part of my 100 days of cloud challenge that I'm jumping into to, try to live stream through these AWS workshops and try and learn some cloud while I'm drinking some coffee. It's hoping it's more of like a focused way of spending like an hour and a half maybe on learning different concepts in the cloud, specifically using these AWS workshops to do that. And I started out with the Modern Infrastructure as Code with Pulumi, because it was actually my contribution to the list of awesome AWS workshops. So those are actually found on the awesome. So you can go to this website and see all the different awesome AWS workshops. They cover a lot of different areas, but yeah, I added or contributed this workshop specifically to the list, and so I thought it'd be a good one to start with. But ultimately, the goal is to, within this 100 days of cloud, is to go through each of these workshops individually and see how far we can get with it, and maybe 100 days of cloud turns into 200 days of cloud or something. I don't know. But yeah, with that said, yesterday we covered module 1, which was basically creating a static website, and then making it like dynamic in a way that we could separate stacks by environments. So we had a dev stack and a prod stack, and Pulumi was actually able to just dynamically read through these directories to find the specific index.html to serve our static website, right? Depending on what environment it was, which was very, very cool, and not something that you would only write, less than 30 lines of code to complete with raw CloudFormation or even Terraform. So I definitely think that is what shows the strength of what Pulumi can accomplish. So it looks like today we are going to look at deploying an Amazon EKS cluster using Pulumi. So yeah, let's dive into module 2. Cheers, and we'll see you on the other side, I guess. I'm also wearing a hat today because yesterday I realized, how much bedhead that I had, and I still kind of look a little sleepy, but I think I like the morning focus time though. All right. Oh, yeah, I also tried to install Starship, but it looks like there's an issue with it. But we'll just continue. All right. So, yeah, warning: you're responsible for the cost of the AWS services. Obviously, there's going to be some cost incurred. I'm pretty sure EKS doesn't fall under the free tier, so something to be aware of. So it looks like we'll create a new project, create a VPC, create an EKS cluster, and test cluster access. So I think we can close that IC workshop, and we'll just just make it there. Yes. I think I said this yesterday, but at the when both these tools like the CDK and Pulumi came out a while ago now. Um, I was very reluctant to like open my mind to using like TypeScript. I was very much like a Python fanboy and didn't want to wander outside of anything that I felt comfortable with Python. But I've really enjoyed using TypeScript. It's not that bad. Okay, so looks like we will install some packages again. Just gonna copy this. Guess I could have done both of them. And then we'll set our region, which I think it's already set to, but I don't think it would hurt to just make sure. Cool. All right. So now we are at the point of creating an Amazon VPC. Let's see. So start by adding the Pulumi AWS X, which, by the way, like if you're not familiar with the AWS X, it's like Pulumi's crosswalk. It's sort of like you can, if you're familiar with CDK, it's kind of like these layer two, layer three like constructs or abstractions that have a lot of like of what they think are best practices built into these like pre-provision like constructs, or like packages of infrastructure as code, right? So like I think we'll use the VPC version of their crosswalks, which is and actually let me pull it up. Uh, I think it should be like right on there. Yeah, so they have a crosswalk for AWS. Let's see what it says. It's like blow that up a little bit more. It's a collection of libraries that use automatic, well-architected best practices to make common infrastructure as code tasks in AWS easier and more secure, which is totally true. And I think once we jump into the VPC one, especially, you'll definitely see the benefits of using stuff like this. But it looks like they have it for like API gateway, auto scaling. I've already started looking into the EKS one, which is really nice. But yeah. Okay, back to the workshop. So let's go ahead and import this. The VPC. Okay, so the VPC will be made of two private, two public subnets. Private subnets will be routed to the internet via NAT gateway. Again, that's built into the crosswalk. So, um, yeah, I mean, and this is it right here. One line. That. So once we do like a pull me up, and kind of see the plan for it, I think that's when you'll really see um, all the resources that are sort of built into this construct. So, okay, yeah. So we'll run pull me up. Oh, I gotta save it first. Let me try that again. Yeah, so just in that one line, we're getting 31 resources to create. It's really nice because it just, takes care of all the subnets, the route tables, the routes. I mean, it's just a time saver. All right, so I think we'll just hit yes. All right, if we go to the next part here, looks like we'll be creating a, yeah, so I think I can just let that run for now. We'll keep an eye on it. So it looks like we'll now bring in the EKS cluster. Excuse me. All right. I like how it links you to the docs and examples. I've definitely got to give it to Pulumi for their documentation. It's really nice. I think it's come a long way. I kind of remember complaining about it on Twitter, and one of the folks from Pulumi reached back out to me on Twitter and said, "Hey, we're definitely working on it," and I can tell like it's really nice and looks really well done. Yeah, like you can filter down into the resources and see some of the different methods and properties that you can apply to it, which is really nice. So props. Okay, so now we will create the cluster. And we're just referencing the VPC here. As part of this AWS X library, it outputs a lot of the resources that it creates, and one of which is this, these private and public subnet IDs. So it's easier to reference them like throughout your infrastructure as code, which is another really nice thing. Okay, and then last, I think, should be when we need the kube config to interact with the cluster, or to, like, see the nodes in the pods that we're going to be running. It looks like it wants us to export the cluster name as well, so we'll just add that. Okay. Cool. Let me go ahead and save that. And then we'll run pull me up again and see how many more resources that we get created. So we already had 31. Now we have 27. I'm going to go ahead and hit yes, because I think it takes a minute for the EKS cluster to, like, get created. But essentially, you can see again, like, part of this library, right? This cluster is that it will create the roles. It'll attach the roles. It's 5 lines of code to do all that. It still just blows my mind, After all that time I spent writing CloudFormation and JSON and YAML, it's just like, can't even explain, like, how nice it is to just wrap all that into 5 lines or so of, and you're building best practices in. Like, so many times I've kind of gone off the reservation of probably adding a little too much permissions to certain things, but this allows you to have that least privilege between the services that you need, not necessarily like just over provisioning and permissions for everything. This is kind of more exact, and I think a phrase that is said a lot is that you're standing on the shoulders of giants, and you're just kind of building off of what they've already made. So it's kind of nice. Okay, so this will create an Amazon EKS cluster situated in the previously created VPC, and deploy a node pool for the cluster, then export the kube config for us to use to interact with the cluster. So it gives you a screenshot of, all the stuff that we saw in our Pull Me Up preview. We're moving pretty quick through module 2, so maybe module 2 is just more of like provisioning and testing access to the cluster, and then we'll dive deeper into module 3. Yeah, so the next step here, testing cluster access. Once the cluster is provisioned, it will output the kube config for us that we can use. And then we can use like the kubectl commands to get more information from the cluster. So I'm not sure, like, if it's been. I'm not sure if it's been like decided or not. Whether it's called Cube CTL or Cube Cuddle, but I'm gonna go with Cube CTL. Hopefully, yeah. Maybe we can check out the docs a little bit more while that's still going. One thing that I've been trying to figure out is I think there's like a method. I mean, yeah, kind of a side note too is like I think we talked about it yesterday, but you know how Pulumi kind of sits on top of Terraform, so you can use all of the same Terraform providers. Which I mean, that's kind of a game changer, you know. Uh, Whereas with like CDK, even though they have CDK for Terraform now, this Pulumi just still feels like a better like workflow in my opinion, or I don't know. It's definitely more mature, obviously, but like I don't. I'm still not sure like why you would pick CDK for Terraform over Pulumi when they kind of do the same thing, and Pulumi's already kind of you know done a lot of the heavy lifting as far as building these crosswalks and stuff that CDK for Terraform. Like you can use like the Terraform modules from the registry, or pre-built modules and stuff, but I don't know. I like, at least from my opinion right now, I don't see the use of using CDK for Terraform over Pulumi, but I guess you know there's a purpose, or whatever fits your needs. It's kind of whatever floats your boat, right? But yeah, and a little side project that I'm working on is trying to figure out how to deploy Vault, HashiCorp Vault cluster on top of EKS, and it's been quite the journey so far. But so there's a Helm chart for Vault which I can deploy, but then I can't figure out how to access it publicly. So I feel like I have to create like a manifest file, and then the deployment and service within the manifest that includes the Helm chart. But yeah, still learning that. Maybe I should probably do a stream on how I do that so I can come back to it later, I guess. But yeah, I mean, this is cool because you can provision like the infrastructure for Vault, right? So if I eventually get cluster, uh, the cluster deployed on top of EKS, I can also bring in this Vault um, package here as well, and sort of configure the Vault cluster on top of, or like in conjunction with the infrastructure. So that's the goal, anyways. We'll see if it works out. But let's look at the. Yeah, so this is pretty similar to what we're already doing. It's just kind of runs you through like how to use the EKS like library with the crosswalks. Yeah, so I think that this is similar to what I need to do, except within, uh, obviously instead of deploying like an Nginx container, I need to figure out how to like um, fit the Helm chart within this deployment. I believe. I that way like that way when I have this service down here with the load balancer, um, it will like serve traffic to the Vault cluster. I think. I don't know. We'll see, I guess. But it's kind of cool. Yeah. So this is it still going? Well, we might not make it through module 2 because the EKS cluster takes an hour and a half to build, I guess. But we'll give it a little bit more time here. Um, yeah, another thing about the Pulumi crosswalk for AWS is that I think it only supports TypeScript right now. So again, if you're in the same boat as I was previously to opening my mind about TypeScript, that might be a game stopper for you. Um, but yeah, there's a lot of cool stuff within Pulumi for sure. Yeah, let's look at the continuous delivery. It's something that I've considered too. Like I want to put it in GitHub eventually, I think, and then have an action that kicks off. So this is cool. So Pulumi can also bridge results from your CI/CD system with GitHub, surfacing the results of the stack updates on a GitHub pull request. See the Pulumi GitHub app for more information. So that sounds like exactly what I want to do. Like I want to put this up into GitHub, and then when there's updates, create a pull request. Kind of. I definitely feel like everything should start to gear more towards that whole GitOps approach. Because right now, I'm going straight cowboy on creating all this infrastructure. Almost 58 different resources from my Cloud9 instance, but um, you got to have a way to share it with your team, and allow your team to sort of provide updates to the infrastructure as well. Like I try to remove myself as a single point of failure. um, and I don't want people to be waiting on me or relying on me to do something, because then that's just more responsibility on my plate, and I'd rather not. Um, so by hosting it or pushing it up to GitHub, and then having a standard workflow or process to create pull requests to update or change infrastructure as code. I mean, that's the goal, right? Like that's what everyone should be striving for, right? In my opinion. And preferably not on Jenkins. Jenkins, I think Jenkins served its purpose a long time ago, but good riddance. There's other tools out there now like GitHub Actions that, I mean, if you're spinning up, if you have the choice or the ability to start new, I mean, you got to pick like something like GitHub Actions or GitLab CI, because there's no point in rolling your own Jenkins cluster anymore. Oh wow, they make it so easy for you to add the Pulumi GitHub app. Look at that. Oh man, that is nice. Yeah, I mean, that looks exactly like something I'm trying to do. So very cool. Looked like we had a little bit of action on our infrastructure provisioning over here, but it stopped again. All right. Let's see what. Hey, there it goes. So finally finished. So now we can use the output from. We can use the output here, which gives us the kube config, and we can output that to a JSON file locally. And then we can export that as an environment variable. And then now we can like interact with the the cluster that we just provisioned. So it says to test. Okay, so we can run like kubectl. Cluster info. Yeah, cool. So it gives us like the endpoint of the EKS cluster. Yeah, just some more information. So kubectl. I'm gonna move this over actually. So kubectl get nodes -o show labels. That's kind of a lot, but let's try cube CTL get pods. So yeah, we don't have any pods running. We should just have nodes because we haven't actually deployed anything on top of cluster, which makes sense. I don't. So yeah, so I mean, just by doing like kubectl get nodes, you can see we have two instances that are part of two nodes that are part of the cluster, and like their versions. Cool. All right, so I think that is module 2. Let's take a look at module 3. I think we should go for it. Yeah, let's go for it. Okay, so in this lab, you'll deploy an application to the Kubernetes cluster in EKS. Okay. Step 1, create a new directory. Each Pulumi project lives in its own directory. Create one now and change into it. Okay. So I wonder if this is like a different, or is it within our I guess we'll back out of this EKS infrastructure directory, and then we'll just make a new EKS apps cd EKS demo apps. Okay, and then we'll install the Kubernetes, the Pulumi Kubernetes package. We haven't used that one before, so all right. So let me close that one, and then let's open up the new index.html or sorry, index.ts from the EKS demo apps directory. Configure the use of a stack reference. Okay, so we'll, oops. Okay, so create a stack reference to the Kubernetes cluster stack using the config cluster stack ref stack setting. So existing, let's see what this comment says. Existing Pulumi stack reference in the format, organization, project, stack. That's kind of cool. Okay. Next, we need to declare a new Kubernetes provider based on the kubeconfig created in the cluster stack. To do this, add this to your index.ts. I like this because it's like, even though we sort of bundled the VPC and like the cluster together, like I can see where you could sort of separate like a network stack, compute stack, where you'd have the cluster, and then this would be like the app stack, and then you just kind of reference across the different stacks and whatnot. So I like this a lot. Cluster stack ref dot get output. And then we just reference config file. Cool. So I think that looks pretty good. Next, declare a namespace object. This will scope your objects to a name of your choosing so that in this workshop you don't accidentally interfere with other participants. Not really the case for us here. Append this to your index.ts file, replacing EKS cluster with your own name and referencing the provider created in the previous step. This is a like a namespace is not something that um, I was really aware of in my like side project using or trying to provision Vault. So it's kind of cool that learning a lot today, I think. All right, so it says you'll now declare a deployment object which deploys a specific set of containers to the cluster and scales them. In this case, you'll deploy the pre-built, gives us this guy here, container image with only a single replica. Okay, so const, I'm going to lower this guy here. I think it's a little bunched up now. Probably looks a little bit better, right? Okay, so const app labels equals app. I love the IntelliSense, right? And like just being able to write a single letter and then get multiple options. Like just the authoring experience still blows my mind. It's really nice. Anyways. Okay, so we're creating the deployment now. So we just need to give it a name, like EKS demo apps dash deployment. We could refactor this probably a little bit as well, like as far as like I can think of, we've kind of hard coded this name of the apps quite a bit. Like that could be a variable that you just pass into each of these. But not a huge deal though. So, okay, so metadata, right? So we give it the namespace inside of the metadata, ns dot name, and then the spec. We're gonna selector. I need to like read up on what these different match labels, these different like components are, because it doesn't make a whole lot of sense to me. Like the spec does, like the spec makes me think it's like these are specific to this deployment, right? But like, what is a selector? Why are we passing in the app labels? Or I guess it's just like a tag, maybe like you're adding that into the spec so that any resources as part of the deployment is tagged with that label, maybe. Replicas, that makes sense because it's like, how many copies of this do you want? That makes sense. So the template, this looks like template. Maybe the template is what I was kind of thinking of. Labels. Maybe, okay, maybe, no. Maybe this is at the pod level then? Like this template would be at the pod level? I don't know. I'll Google it later. Maybe come back tomorrow and figure it out. But just trying to make it through module 3 here, I think. So the name, oops. Name EKS-demo apps. Image. Copy that. Cool. I don't think that all these trailing commas are absolutely necessary. I think we just need to add the provider here. And then this one needs the semicolon. All right. Looks good. Kind of wish it would. Oh, there is. I was just gonna say, like, I wish it had some kind of like documentation on what a deployment is, but it's got us covered. So deployment provides declarative updates for pods replica sets. You describe a desired state in a deployment, and the deployment controller changes the actual state to the desired state that at a controlled rate. Yeah, it's interesting. So like if you were to write it in YAML, this is sort of what it would look like. And then obviously we're using TypeScript here. So And like I said, I think you can like refactor it to make it look a little bit better in that you can sort of abstract the name of the app, right, and make that like a variable that you can pass in. So like it makes it a little bit cleaner in that way, I guess, because obviously with YAML, I don't think you can pass like variables and stuff. So, but yeah, this looks kind of cool. That um, oh, they, you know, I think this is the section that I probably need to read since I've figured out how to get my side project to deploy. I just need to figure out the services and networking and stuff, so load balancing and whatnot. um, cool. So that looks like something I'll be diving into later. All right, so in the next section here, declare an application service object. I wonder if this takes us to that services section. Yeah, so uh-oh. um Looks like I got logged out, so darn it. Let me just log back in here. I think it's on like a 60-minute timeout, and you gotta log back in. All right, we're back. Oh, that's cool. You can go full screen, so you can't see my face anymore. But then you can't see, my cool little background. All right. Anyways, so yeah, here's some good reading on like services inside of Kubernetes. Um, Definitely something to read about. So now we're gonna add that uh, to our Pulumi stack here. So let's just add it down here. So const service. Metadata name. So it's kind of similar to the deployment. But this is more of like the service, like the networking part of the deployment, I guess. So we specify the port. Um, and then the type is load balancer. We just have to add the provider. I'll be interested to see if this is like an application load balancer, or because I think that Kubernetes has to have like its ingress. Um, yeah, if it's either like if this actually creates a like an actual like AWS load balancer, or if this is like a load balancer specifically within the Kubernetes cluster. Like, I have no idea. Okay, so AWS ALB ingress controller enables ingress using the AWS application load balancer. Yeah, so we'll see. I'm not too sure. Okay, so then we're gonna export like the address of. I'm just gonna copy this in here because it looks like we're just outputting the address of the load balancer, it seems, so that we can access the services that are running in the cluster. So hmm. Oh, that's cool. Okay, so like we're able to kind of like parse through the service and get the the uh, the address right of the service, and then the port as well. Although so basically we're not like hard coding it in the output section, which is always a good thing. Okay, so that should be good to go. All right, deploying our application stack. Okay, so looks like we need to add this stack reference to our like Pulumi config. Which is really nice. I mean, uh, that seems pretty handy. Okay, so then we write pull me up. Uh-oh. Okay, so we don't have a workshops. Maybe if I just remove workshops, because we just created a directory called EKS infrastructure. Not. Let's try that. Organization project. Okay. So what is my organization? Oh, I think it's right here. So Be Gringo is the organization. Let's try that. There it goes. Cool. Okay. So yeah, if you didn't know, where it gives you this like live preview that takes you to the Pulumi SaaS, you can see like the your organization name is within the URL of that link. Um, okay, cool. So you set the stack reference. Now we're deploying the apps on top of that cluster that we created in the previous module. And I think we should still be able to like use our kubectl. Yeah. So after this deploys the services or deploys the pods, then we should be able to see it um, using our kubectl. Cool. Looks like it's working. So update application version. Next, you'll make 2 changes to the application. Scale out to 3 replicas instead of just 1. Update the version of your application by changing its container image tag. Okay, so first we'll update the replicas from 1 to 3. Okay, and then update the image to this guy. All right, and then we'll pull me up to make those changes. So, another thing. So yeah, well, let's um, let's check out the pods again. Cool. So we were able to see like it was terminating the old ones apparently, and spinning up new ones. Cool. And then it says you can curl here, but we got the output URL. So let's see if we can open up a tab and actually see it within the browser. Yeah, cool. So let me zoom in on that. So we're getting the hello Kubernetes bootcamp, and then it tells us what pod we're running on with what version. Pretty cool. Oh yeah, so you can loop through and see the response, or the response, what it says from each of the different pods. But I think you get the point of it. Cool. So destroying your infrastructure. So So I think it's important. So this will actually destroy. Let me destroy. This will destroy like the apps that are on the cluster, but we got to remember to change into the directory to delete the the actual resources that are incurring the cost. Maybe they should add that to this section of the workshop. But yeah, module 3, that was pretty cool. I'm like still very much new to like Kubernetes, and like the different components that are involved with it. But I think this was like really cool, you know, a really cool workshop to go through to just get a cluster up and running, and then services deployed on top of it in pretty quickly. So let me go. Oh, let me move this stack. Okay, and then EKS, was it infrastructure? And we'll do Pulumi destroy 58 resources gone. Cool. Yeah. So again, we went through creating, the infrastructure, the namespace, and then the applications that deploy on top of the cluster. Um, that was module 3 was really cool. Module 2 and 3 actually. So if we look forward a little bit, in module 4, it says creating infrastructure components in Kubernetes. So in this lab, we'll extract a common Kubernetes infrastructure of creating both a deployment and a service pattern into a reusable service deployment component. Cool. So I think what they're trying to do is, take you through sort of like the traditional way of provisioning infrastructure as code. Like that module 2 and 3 is probably what I would have done by myself, but maybe module 4 now will be more of like creating like more reusable components that are sort of easy to bundle up and whatnot. So I think that's what we'll hit on tomorrow. This is only day 2 of 100 Days of Cloud. So I'm going to stop here, I think. And yeah, that was a fun one. So, all right. Thanks for watching. See you next time.